Hi, I am Sankhaneel Bisui. I am a PhD student at the Department of Mathematics at Tulane University. I am working under the supervision of Professor Tai Ha. I would like to thank the organizers, Eloisa and Sean, for giving me the opportunity to talk about my work in this beautiful virtual seminar. I would like to give a brief description of the motivating question that inspired my work. It was raised by Nagata and it's asked about, given a set of distinct points inside the projective space, what is the least degree of a homogeneous polynomial that will vanish at each those points with certain multiplicity? Now, Zariski and Nagata's theorem provides us an algebraic platform to study this geometric problem. First, it gives us an easy description of the symbolic power of the defining ideal involving the ideal defining each point and their ordinary power in this manner. Now, secondly, it says the answer to the question is just the initial degree of the teeth symbolic power of the defining ideal of X. Again, the Wall-Smith constant, which is defined by the limit of the ratio of the initial degree of T symbolic power with T, and it is well defined, and to study the Nagata's question is same as to study the Wall-Smith constant. Now, in general, the study of the Wall-Smith constant and its exact values is really difficult. And more desirable thing is to study the lower bound of the Wall-Smith constant. Now, if Ix defines the ideal for a set of points, then Chudnovsky's conjectural lower bound for the Wall-Smith constant is given by the initial degree of the ideal defining X plus n minus 1 over n, which was later on generalized by de Mailly by saying the lower bound is the initial degree of the mth symbolic power plus n minus 1 over m plus n minus 1. Now, the key idea here to study the stable containment and specialization, that's the idea we used. All our joint work with Eloisa Griffo, Tai Ha, and Thai Ngoc Nguyen are in archive. The containment problem illustrates which symbolic power of an ideal sits inside what ordinary power of the ideal. Now, Harborn conjectured that for an ideal with big height h, the hr minus h plus 1th symbolic power sits inside the earth ordinary power of the ideal. Harborn and Hunicki strengthen the containment by applying appropriate power of the maximal ideal on the right-hand side of the containment. Now, the first containment implies the Chudnovsky's conjecture and the second containment implies the de Mailly's conjecture. So what I study the stable version of all this containment, meaning the containment for all are big enough. The key idea is to prove one containment implies the stable containment and specialization. All the results from our joint work with Eloisa Griffo, Tai Ha, and Thai Ngoc Nguyen about large number of general points and containment are in archive. Next, I would like to talk about some other projects that I have worked on. So the first one is the resurgence of fiber product of ideals. It is easy fact that the asymptotic resurgence is at most the resurgence for any ideal. Our goal was to study the difference. We were motivated to find out a family of ideals, possibly in a different polynomial rings, such that when we take the difference between the resurgence and the asymptotic resurgence, that number would be as big as possible. Now, all our joint work with Tai Ha, A.V. Jayantan, and Abu Thomas has been published in Collectina Mathematica. The next project was about stability index of the regularity and the A-star invariant. And this project was motivated by the result of Eisenberg-Harris, Taiha, and Chardin, which states that basically with some conditions, the A-star invariant and the regularity have an asymptotic linear behavior. So we wanted to study the stability index of the regularity and the stability index of the A-star invariant. And all the results from our joint work with Taiha and Abu Thomas has been published in Acta Math Vietnam. Next, I would like to talk some about the future directions. So I am interested in the conjectures, meaning the Chudnovsky, De Mailly, and Harbon-Hunicki conjectures for smaller number of points. I am also interested in containments of ideals coming from different setup, meaning combinatorial, maybe different arrangements. I am also interested in the study of the Hilbert functions of a fat point scheme. Lastly, I am also interested in the SHGH conjecture that predicts the maximal Hilbert function for fat point schemes. And thank you for listening. And that's my contact details if you want to reach me. And again, thank you.